Okay, hello. So this is another video, this time on solving reciprocal trig equations. So this is very much part of exercise 6a. I think questions 5 and 7 are like this. And this isn't too bad, really. I think it works in a very similar way, to the trig equations that we were solving last year. And I'm starting off straight away with one, I guess a more difficult one, if you like, but it's not that bad. So we've got 2 tan squared theta plus 7 sec theta minus 2 equals 0. It's asking us to solve it in the range of theta being between 0 and 2 pi, which immediately tells me, I'm sure you'll agree, that we're in radians. Yeah, so sometimes it will be in degrees, sometimes it will be in radians, but it's quite straightforward to. I think in the exercise I only do it in degrees, which is a bit annoying, but let's solve this one in radians because it will be good fun to do so. Now, the problem here, of course, just like last year when you were solving these kinds of equations, is that this expression inside the equation is in terms of tan, and this one's in terms of sec. So it'd be nice if we had, because this kind of looks like those trigonometric quadratics, or if you prefer, can I call them quadratics in disguise? This looks like it's going to turn into a quadratic in disguise, but we really need to write it all in terms of the same trig function. Now, what's going to help us here is that identity, which in the other video I said was very, 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 very important, and that is use 1 plus tan squared theta, or x, or whatever the argument is identical to sec squared theta. Yeah? If we use that, we can replace tan squared with sec squared minus 1, and hence write the whole expression down solely in terms of sec. So this is the same as 2 sec squared theta minus 1 in brackets, plus 7 sec theta minus 2 equals 0. Now it's just a case of tidying up the trig function. 2 sec squared theta plus 7 sec theta, and then I've still got the minus 2, which I kind of ignored there. With another minus 2, that makes minus 4 equals 0. And yeah, it's a quadratic in disguise. It is absolutely a quadratic in disguise. So start factorizing it. We're going to have 2 sec theta and a sec theta. I want to make minus 4, but I want 7 in the middle. So I guess a plus 4 here and a minus 1 there will do the trick. And that gives us sec theta equals a half, because that bracket is 0, or this bracket is 0, in which case sec theta is minus 4. Now, at the end, convert sec to sec is 1 over cos, yeah? Always use the third letter. I don't know if I've mentioned that, but if you've got sec, cosec, and cotan, or cot, it's the third letter which tells you whether it's sin, cos, or tan's reciprocal. It was a student who pointed that out to me. I just remember it works back to front, but everybody, when I say that to students, they always seem to love that way of remembering it. So there you go, third letter if you like. Okay, so this is 1 over cos theta is a half, in which case cos theta is 2. And that's got no solutions, because cos theta never gets as high as 2. It only goes up to 1. So you can cross that out. This gives us cos theta, well, 1 over cos theta, if you like, is minus 4. And hence cos theta is minus a quarter. Normally I'd go straight to cos theta is minus a quarter there, but it doesn't matter. Now we've just got to make sure our calculator's in radians, which is always easily forgotten, and do inverse cos of minus a quarter. And I haven't got my calculator nearby, but I'm using the example from the textbook. It tells me that it's 1.82 radians. Rule of thumb for cos, 360 minus normally if you're in degrees, but 2 pi minus if you're in gradients. Gradients? What on earth is a gradient? Radians. Radians if you're in radians. 2 pi minus the first answer gives you 4.46 radians for the second answer, and you've solved it. Okay, to finish off, because I'm just going to do a couple of examples, because there's not loads of these in the exercise, but I do think solving trig equations is important. Let's try and solve these equations. Sec 2x. Oh, in fact, I might even do that one. 3 cosec squared 2x equals 4. For 0 is less than or equal to x is less than or equal to 1 80. So we're in degrees this time because it's given the range in degrees. Okay, think about what's happened to x first. First we doubled x, then we took the cosec of it, then we squared it, and then we multiplied it by 3. So going backwards, go in reverse. Cosec squared 2x is 4/3. So cosec 2x is 2 over root 3. Don't forget the plus or minus. Really easy to do that. In fact, you're better off in some ways writing it separately just to remind yourself that you've got two equations to deal with here. I like writing down root 2 over 3 or minus root 2 over 3. That means now cosec is 1 over sine 2x. Do you mind if I just go straight to sine 2x equals, I need to take the reciprocal, so it's hang on a second, I've got that. Hey, a mistake. Did you spot the mistake? Were you sitting there thinking, what's he doing? Sorry about that. I've just spotted the mistake myself as I'm waffling on. Square root of 4 is 2. Square root of 3 is root 3. And then you get the -1. So sorry about that. I knew I'd made a mistake because I thought at the time, oh, that's nice, because when I turn it upside down, I'm going to get the very well-known trig function, root 3 over 2 or minus root 3 over 2. And I suddenly looked in horror. Okay, so carrying on going. So look out for little mistakes, they creep in. Let me know if you see any in any of my videos. I'll be absolutely mortified and you get the right to gloat. Okay, inverse sine of root 3 over 2. I think sine 30 is a half, so sine 60 must be that one. And so I think it's going to be 60. Rule of thumb for sine, 180 minus, so I'm going to get 120. Oh, by the way, though, 2x is between 0 and 360. So I think that's all the ranges for sine there. So that's fine. So in the end, we're going to get x is 30 or 60. Yeah, and you can check these at the end, remember, because you're solving. If, on the other hand, we had inverse sine of minus root 3 over 2, that's going to give me on my calculator minus 60 first, but do 180 minus 60 and you'll get 240. Or you could have done add 360 to minus 60 and got 300. And then, oh, it's a bit funny, 300. Then halve them at the end, you're going to get 120 or 150. I hope that is correct. I'm actually going to quickly check in the book because it's really easy to mess these things up or miss solutions, that kind of thing. Do check all your answers as soon as you've done them. What question was that? 11B that was. And they're all correct. Good. Okay. Hope that's helped. Best of luck. And please do get in touch on the Maths Help Desk if you've got any questions. Okay. Bye-bye.